In this last mini lecture on plant breeding, we'll talk about the second breeding scheme that I showed you. And here it is again. So we have our existing plant. Let's say that we can't do the first breeding scheme because there's just nothing closely related to this plant at all that has the characteristics that we want. So what we're going to do instead is try to induce mutations. So we're going to zap it, see if we get our desired plant, and then once we have it, again, we'll asexually propagate it so that we can then sell and distribute it. So how do you zap it? How do you induce mutation? With your mind. Now, you guys aren't buying it. That's what I'm trying to do here. Those are some of my research plants too. It didn't work. However, I am growing them in tissue culture, and this is something that often does work. Sometimes just the tissue culture environment gives rise to more mutations than if you're growing a plant normally. And so that's one way to try to get a mutated plant or to zap it, is simply to grow it in tissue culture. A second method is to expose the plants to chemical mutagens. A third is to induce polyploidy, and polyploidy is when we have multiple copies of the genetic material. So usually we have 2 copies of all the chromosomes, although that's not always the case. Well, a polyploid is going to have more than 2 copies of the chromosomes. So again, here is tissue culture, and this plant is a very good example of a plant that we didn't have anything to cross it with to get our desired plant. This is an ornamental St. John's wort, and the particular species we were working with has bluish green leaves and nice bright yellow flowers. It's a nice compact shrub. The issue is we wanted something a little different. We wanted to jazz it up a little bit, and so we were trying to get different color flowers or different color foliage, so some purple foliage or some variegated foliage. And there was just nothing closely related to this plant that we could cross it with to get different colored flowers or foliage. Everything closely related to it had yellow flowers and bluish green leaves, so we had to zap it. So the first thing we did is grow it in tissue culture. Here on the left, you can see the shoots that initially formed. We used leaves for the explants, and then on the right, you can see we've grown them on. They're a little more plant-like, and eventually we took them out of tissue culture and grew them into adults. However, we did not get our desired plant. So the next thing we did is expose it to mutagens. So here you can see the plant. Again, it's an attractive flower, it's an attractive shrub, but we want something different. So we grew this plant in tissue culture, we didn't get anything different, and so then in tissue culture we took some of those tiny plants and exposed some of them to chemical mutagens, and some of them we sent to the nuclear reactor on campus and exposed it to radiation. This also didn't work, just in case you were wondering. The plants that we exposed to high levels of mutagens, whether it was the radiation or the chemicals, they died. The ones we exposed to low levels of mutagens looked just like this. There wasn't really any change. They were just like, oh, did you expose me to horrible radiation and chemicals? No big deal. Plants are resilient like that. So, basically, we failed at that, in case you're wondering how that story ends. But that happens sometimes. Well, what about polyploidy? I've discussed this before, but here is a plant. This is a rhododendron, and this is a cultivar called Nova Zembla. Now, it's a pretty attractive rhododendron. However, what if we can make it look like this? This is the rhododendron cultivar called Supernova, and the only difference between these two is that Supernova is a polyploid version of Nova Zembla. So all they did is they doubled the genetic content of Nova Zembla, and they ended up with Supernova. Now when you do this, when you induce a polyploid, often you get a lot of desirable ornamental traits, such as more flowers, larger flowers, longer lasting flowers, thicker leaves, thicker petals, and also sometimes a more compact growth form, which could result in a dwarf shrub, which is something we might like as well. So inducing polyploidy is just another way to zap your plant, as it were, and this is usually done in tissue culture by applying a certain chemical to that as well. So to zap your plant, you can grow it in tissue culture, you can try to induce mutation through chemical mutagens or radiation, or you can try to do it by specifically exposing it to a chemical that will create a polyploid. And it could be doubling the genetic content, quadrupling it, and so forth. There's really no limit as long as the plant can still grow successfully. Which brings us back to the tale of our seedless watermelon. It's even more complicated than you thought. A lot of work goes into these. So, your regular seeded watermelon is a diploid. It has 2 copies of all its chromosomes. To get the seedless watermelon, what they actually did is they took a diploid watermelon and they induced polyploidy so that they had a tetraploid watermelon that had 4 copies of all the chromosomes. Then they crossed the diploid watermelon with the tetraploid watermelon. So that's 2 copies plus 4 copies equals 6 total copies, and through meiosis what we get is offspring that have 3 copies of the chromosomes, triploid watermelons. So the seeds produced from that cross yield triploid watermelons. Those triploid watermelons are sterile because now when they try to perform meiosis to sexually propagate and produce seeds, what happens is they can't divide evenly. You can't have 1.5 chromosomes. And so they don't produce seeds, but they still produce fruit through parthenocarpy, and they still have to be pollinated, but they don't produce pollen themselves because they're sterile, because they're triploids. So what they do is they grow a bunch of diploid watermelons, they induce polyploid to get a bunch of tetraploid, they cross them, they get the triploid seed, which they plant out in the field, which gives us lots of triploid watermelons. But every few rows they'll plant also the good old diploid watermelon, which will produce pollen, which will pollinate the triploids to stimulate parthenocarpy so they produce seedless fruit. I hope I've blown your mind on that. In any case, you should appreciate seedless watermelons because a lot of work went into them. One of my best friends is a middle school science teacher, and she hates seedless watermelons. She prefers the seeded ones, and she always tells me that seedless watermelons are freakish mutants. I tell her they're not, but actually, kind of they are. So that's our 2 breeding schemes, and one thing I also want to touch on before we close this topic are the legal issues associated with plant breeding. You can now patent new plants that you've bred just like you can patent any other invention. So if a plant is patented, nobody can propagate it without your authorization if you're the patent holder. The plant patent lasts for 17 years, although I think they might have increased it to 20. And don't ask me why it was 17 in the beginning, because that's a very random time period, but there you have it. Now, usually to get your authorization to propagate the plant, people have to pay you for that right. They have to pay you some sort of royalties. So it is actually illegal to propagate a patented plant without that authorization from the patent holder. So don't do it, guys. So we have plant patents and we also have trademarks. Now the plant patent is on the actual plant. A trademark is ownership just of the plant name. It's a marketing tool, just like trademarks are for anything else. And so here's an example. Proven Winners is a trademark line of plants with a large nursery known as Spring Meadow Nursery. So they have a lot of these trademark plants, and the flowers shown here, if you don't already recognize them, these are known as knockout roses. Now, knockout is a trademark name, so if anyone wants to sell these roses as knockout roses at a nursery, they have to pay for the trademark. They also have to grow them in a specific pot that has the trademark symbols on it. And of course, you have to pay for all of that. Now, to be extra tricky, when they named the cultivars of these plants, they gave them really weird cultivar names that no one would remember, like Radcon and Radio. Okay, I remember them, but I'm not normal. So, by giving them these cultivar names that they can't trademark and that no one will remember, they ensure that the only way the nursery is going to be able to sell this plant that the public recognizes is to use the trademark name, Knockout, rather than the cultivar name, which no one knows. You could sell it by the cultivar name without paying the trademark fees, but no one would know what it was. And lest you think this is something people can easily get around, it's not. Okay, so if you as a homeowner propagate a patented plant without permission, no one is probably going to find you and prosecute you about that. I'm still not saying do it. I'm just saying they're not after homeowners. What they're after are nurseries that do this, because nurseries can produce a lot of patented plants without paying for it and make money. And so they don't want that happening. And because of that, there is a company called PlantWatch, and their whole purpose is to check nurseries to make sure they're not growing patented plants and trademark plants without paying the appropriate fees. Usually you have to sign, if you're going to work with a patent plant, you have to sign a contract that says, I'm only going to propagate this many. And when you sign that, it usually says in there that you give permission for the PlantWatch people to come inspect your nursery and make sure you're doing everything right. They also take anonymous calls if you want to report someone, which is a little big brother, but the point here is if you're going to commercially grow plants, you really need to be careful that you're keeping things legal with your plant patents and your trademarks. I'll close by just showing you all some NC State introductions. We do have a very healthy ornamental plant breeding program here in the horticulture department at NC State. This is one that was released by my grad school advisor, Dr. Tom Rainey. This is a hydrangea, and Invincibelle is the trademark name, Spirit is the cultivar name. He does not do the tricksy false cultivar name so you can only remember the trademark name thing, because he's not that tricksy, but it is patented. And this is not the type of hydrangea that you've seen that produces the large blue balls of flowers. Those are only cold hardy to about zone 7 or maybe 6. This hydrangea is cold hardy to zone 4, so it's much more widely sold, and it used to only come in white. He was the first to release it in pink, and so it was a big release. And you want something like that that's going to make a lot of money before you bother to patent it, because patenting a plant costs a lot of money. If you do it yourself, maybe around $2,000. If you hire a lawyer, around $10,000. It is very tedious. You have to provide a very detailed description of the plant. For example, for a plant like this, you're going to have to tell them the average number of flowers in each flower cluster. Well, how do you know that? Oh, you just have your grad student count all the flowers in the cluster. Yes, that was me. Here's some more. I'm not bitter. It's cool. Good experience. So here's another one. This is released by Dr. Denny Werner, another plant breeder in the department. This is a butterfly bush. The cultivar is Blue Chip. The trademark is Lo and Behold. And he has a whole line of these now. These are all dwarf butterfly bushes that will only get 3 to 4 feet tall instead of 8 to 12 feet tall as butterfly bushes will get if you don't prune them back every year. If you prune this one back every year, it'll stay at 2 to 3 feet tall as opposed to, say, 6 to 8 feet tall like a normal sized one. So a dwarf butterfly bush, he has ones in different colors now, so there's Ice Chip, which is white, etc. He also has some even smaller butterfly bushes he's getting ready to release called Microchip. I think there's Pink Microchip and I forget the other one, but they stay even shorter. These are all ornamental sweet potato vines. These were also bred here at NC State, and these are different cultivars all within the series Sweet Caroline. A lot of times the trademark covers a whole series of cultivars instead of just a single one. So the Sweet Caroline sweet potatoes are NC State releases from our sweet potato breeding program. Here's another one from Tom Rainey. This is the flowering quince. Quinces usually have thorns. This one is thornless, and these flowers are double flowers instead of single flowers. And there's a lot more of them than what you'd find on a regular quince. So the cultivar names for these are Red Storm, Pink Storm, and Orange Storm, and the trademark series name is Double Take. This is another of Denny Werner's, the Merlot Redbud. It has these very glossy purple leaves, and it's a lot more heat tolerant than a lot of our red buds. And then finally, here's mine. Now, I did not breed this plant, but this was one that I did my research on. I evaluated it for disease resistance after it was bred, and I did research on propagating it. So the Gordelinia, which was produced from that example I showed you with wide crosses, cultivar name Sweet Tea, it's not patented. So we did release it to the public, but we didn't patent it because it's a very obscure plant. Only really plant nerdy people know about it, so we're not going to make enough money off it to justify patenting. But it is very beautiful, is it not? Just say yes. And with that, we're going to close the lectures on ornamental plant breeding.